Okay, question 12, circles and coordinate geometry. So figure 12 shows the circle x minus 1 squared add y add 1 squared is equal to 25. The line 4y is 3x minus 32 and the tangent to the circle at the point A 5, 2. D is the point of intersection of the line 4y is 3x minus 32 and the tangent at A. Okay, 14 marks altogether if my maths is right, but one wants us to write down the coordinates of C, the centre of the circle. Okay, so circle centre A, B, radius has equation x minus a squared add y minus b squared is equal to r squared. Therefore, part 1, the centre is, well, the equation is x minus 1 squared add y add 1 squared. So the centre is going to be 1 minus 1. Cool. Okay, part 2a wants us to show that 4y is 3x minus 32 is a tangent to the circle. Okay, so we know it's this bottom line, that's 4y is 3x minus 32. So, if if 4y equals 3x minus 32 is a tangent, then solving the equations simultaneously will give exactly one solution. Okay, so we know then that 4y is 3x minus 32, so y is 3x over 4 minus 8, just divided through by 4. So, now the circle is x minus 1 squared add, well, y is 3/4 x minus 8. So we get 3/4 x, then we got minus 8, but plus 1. So that's going to give us minus 7. Oh, squared. We know that is 25. Expanding the brackets, we get x squared minus 2x add 1 add 9x squared over 16. We get minus 7 times 3/4 x twice, so that's going to give us minus 42. So minus 42 over 4 x add 49. That's all equal to 25. Okay, so we got 1x squared add 9/16 x squared, and that's 25 as x squared over 16. We got minus 2x minus 42 quarters x. 2x is 8 quarters x. So we got minus 8 quarters x minus 42 quarters x. We've got minus 50 quarters x. And then we got 1 add 49, which is 50. And that is all equal to 25. Okay. So as with any quadratic, we need everything on the same side. So let's bring that 25 over by subtracting it. So 25 x squared over 16 minus 50 over 4 and 25 is equal to 0. Now then, let's multiply through by 4. If you use a calculator, just multiply through by 16. But it's early, I'm going to go step by step. So multiplying through by 4, we're going to get 25 x squared over 4 minus 50 x add 100 is equal to 0. Multiply through by 4 again. 25x squared minus 200 x add 400 is equal to 0. The common factor of 25, so divide that away, we get x squared minus 8x add 16 is equal to 0. Now this factorizes to x minus 4 squared is equal to 0. So x is equal to 4. Now that means then there is only one solution. Although I'm also going to go through and find the y value too. So you would be alright to stop there as long as you now said therefore there is only one point of intersection, so the line is a tangent, but I think we're going to need the y coordinate anyway. So x is 4 gives y is 3 times 4 over 4, so that's 3 minus 8 gives us minus 5. So the only point of intersection is 4 minus 5, so the line is a tangent. Cool. Okay, then part B wants us to do exactly what we just did, work out the coordinates of the point of intersection of the tangent and the circle. So we just done that, it was 4 minus 5. So let's start putting this info on the diagram. So we know this is 4 minus 5, we know the centre of the circle is going to be about there-ish. We know that has coordinates 1, -1. Cool. Part 343 marks wants us to prove that ADBC is a square. 3 marks. Okay. So, let's join the points up. So, we need a few circle theorems here. So, first of all, we know that AC and BC are the same length because they are both a radius of the circle. In the real thing, you would want to be writing down some of these points. We also know that a radius meets a tangent at 90 degrees. Now what we can also do is work out the gradients of AC. So we know A has coordinates 5, 2. The question told us. So the gradient of AC is 2 minus 1, which is 3 over 5 minus 1, which is 4. Now the gradient of BC is minus 1 minus 5, so that's 4 over 1 minus 4, which is minus 3. So that's minus 4/3. Now, those two gradients multiply together to give us minus 1. Therefore, AC and BC are perpendicular. So, that means that this angle is a right angle, which must mean that this guy over here is a right angle. Only thing it can be, the other three are right angles. This one has to be. So, at that point, we do at least know that this is a rectangle. Now we need to check that the lengths are all the same. Okay, so this diagram is getting a little bit crowded. Let's just make a neater one down here. So, we know that tangents hitting a circle that come out of the same point are the same length. So we do at least know this length is equal to this length. Now, what we can do is we know this point is 5, 2. We know this point is 4 minus 5. What we can do is work out the length of the diagonal of the square. So that height is 2 down to minus 5, so that's 7. and the length is 4 to 5, so that's 1. So we know the diagonal, let's call it little c. We know c squared is 7 squared and 1 squared, which gives us 50. Now that we know what c squared is, we know that c is root 50. So, let's make another little sketch. We now know we got a right angle triangle where the hypotenuse is root 50, and we know the two other sides are the same length. So let's call them x. So again, by Pythagoras, we know x squared and x squared is 50. 2x squared is 50. X squared is 25. So x is 5. So now we know this shape, or that one, this one, now we know that we have a 4-sided shape with 4 equal sides and 4 right angles, therefore it's a square. Cool. Okay, then for the final part, we are told the point E is the lowest point on the circle. We want to work out the area of sector ECB. Okay, so 5 marks, by the way. Right, so we know the centre is 1 minus 1. Now we know the lowest point on the circle is directly below the centre. So we know the x coordinate at E is 1. Now we know that this point is a radius below the centre. The radius is 5, so the y coordinate is minus 6. So we know the coordinates at B are 4 minus 5. It's turning into a triangle. Okay, so what we want is the area of that sector. To be able to work out the area, we need to know the angle at the centre. So we need to know this guy. Now we know these two side lengths are 5 and 5. What we can also do is work out the length EB. So let's take that one in turn. We got this little right angle triangle EB. We know the length is 3. Yep, 3. And we know the height is 1. So we know 3 squared and 1 squared is EB squared. Therefore, EB is root 10. Okay, so if we call the angle theta, and let's make a little sketch. Okay, so we got side of 5, side of 5, side of root 10. So this is now a job for the cosine rule. Okay, so let's call the angle A, and then we know that by the cosine rule, root 10 squared, so 10 is equal to 5 squared at 5 squared, so 50 minus 2 times 5 times 5 cos of A, so minus 50 minus 50 cos A. Okay, so we can get 50 cos A is equal to 40. So cos of A is 4/5. Now inverse cos 4/5, and we will get, bear with me, we get 36.87. So A is 36.87 degrees. So the area of the sector is 36.87 over 360 times pi times 25, so times 25 pi. So that is going to give us 8.04. Cool.